Chapter 3, Part 2, IUPAC Nomenclature of Alkanes and Classifying Hydrogen and Carbon Atoms. So, the IUPAC rules, there are 8 of them, and what I found is that anytime you have some sort of question kind of brewing in your mind of, well, what if this and what if that, it's typically the next rule. So as you're watching this video, you might come up with some questions, but I think if you keep watching, you're going to be fine. So the first rule is to find and name the longest continuous chain. So I have an example down there at the bottom, and our longest continuous chain is 5 carbons long. That means our parent chain is pentane. So pentane is going to be part of the name of our molecule. Now you'll also notice that we have a 1 carbon decoration, and we're going to have to reference that as well. The next part says to number the parent chain starting with the end closest to the substituent. The substituent is closest to the left side, so we're going to number starting from the left. And then we use that number, which is the locant, to designate the position of the substituent. So on carbon number 2, we have a 1 carbon decoration. A 1 carbon decoration is called methyl. So this compound is called 2-methylpentane. Sorry, there should not be a space between those words there. I was hoping I could drag those together. Let's just put that L flat in the middle there. So 2-methylpentane, no space between the words. If there is more than one substituent, you give the substituents the lowest possible numbers and arrange alphabetically. You're going to see this phrase over and over. Anytime you're not sure where to start numbering, it's always that you need to give the lowest possible numbers, unless there is some other priority, and that's not going to come up until we get to things outside of alkanes. And then also arrange alphabetically is the other kind of tricky part here. So for example, in this molecule, we have a longest carbon chain, which I'm going to start numbering from the left because that's closest to my first substituent. And it is 6 carbons long. So hexane is my parent compound. And I have 2 different decorations. I have a methyl group and I have a 2 carbon group, which is called ethyl. The methyl group lives on the 2nd carbon, so that would give me 2-methyl. I'm going to list these up here. And then I would also have 4-ethyl. So what it means by the lowest possible numbers is, let's say I accidentally numbered from the right-hand side instead of starting closest to my substituent. From the right-hand side, my numbers would be 1, 2, 3, 4, 5, 6. Notice that the numbers 3 and 5 that I would be using as my locants are larger than 2 and 4. That's never the goal. We always want to end up with the smallest possible numbers. So that's what that rule means. And then it says to arrange alphabetically. So the next part of this is to take these 2 and using the names of the substituents, we want to arrange them alphabetically. So E comes before M. So we're going to call this 4-ethyl 2-methylhexane. Sorry, I don't know why my pen is leaving gaps. Okay. So I also want to talk about this abbreviation that I'm using. You'll notice that I'm using hyphens to separate numbers from letters. So anytime you need to separate a number from a letter, you use a hyphen. And when we get to another scenario where we use different punctuation, I'll write all these rules out for you. When you have 2 substituents on the same carbon, you use that number twice. So here's another example. You'll notice that these are actually the same 2 substituents we had above, and is also the same parent compound. So we have 1, 2, 3, 4, 5, 6. I'm numbering from left to right because my substituents are closest to the left. So I'm going to use my number twice as my locant. So my substituents are 3-ethyl. I'm going to go ahead and put them in alphabetical order. 3-methyl. And then I finish up with hexane because my parent compound is hexane. So I'm using my locant twice, and I'm still keeping my substituents in alphabetical order. When two or more substituents are the same, use a prefix to indicate multiples of the same substituent. This uses different prefixes from our IUPAC prefixes. So when you have 2 of something, you use di. When you have 3 of something, you use tri. And when you have 4 of something, you use tetra. So for example, in this compound, I have 2 methyl substituents. And I could number from the left or the right. I'm going to number from the left because that's a little easier for me, because my substituents are flat in the middle of the compound. So this has the parent compound pentane because my longest carbon chain is 5 carbons long. So I get pentane as my parent compound. And I have 2 methyl groups that both live on the 3rd carbon. So this is that 2 or more substituents are the same rule. Instead of saying 3-methyl, which is kind of redundant, I'm going to say 3, 3 dash dimethyl. So the di tells me that I have 2 methyl groups on the same compound without having to list out a whole bunch of repeat groups. And then I'm grouping my locants together because I'm using them to describe my 2 methyl groups. Now notice that when I'm separating numbers from numbers, I'm going to use a comma. So the general rule for punctuation in IUPAC is if you're separating a number from a number, you use a comma. If you're separating a letter from a letter and they actually have to be separated, you use a comma. You'll see this for the first time when we get to chapter 4. And then if I need to separate a number from a letter, I use a hyphen. And if I'm separating a letter from a number, I use a hyphen. So separating 2 things that are the same, use a comma. Separating things that are different, use a hyphen. Now, these happened to have my multiple substituents on the same carbon. My next example has multiple substituents on different carbons so that we can see what that would look like for the nomenclature. Now, for this one, I actually have to number my longest chain starting on the right-hand side because it's the closest side to the substituent. So my parent chain has 7 carbons in it. My prefix for 7 is hept. And just a reminder, I'm using the AN infix because all of my carbons are single bonds, and my suffix is E because this is still a hydrocarbon. Now let's list out our different substituents here so that we can make sure that we're alphabetizing them correctly. So on my 5th carbon, I have an ethyl substituent. That's going to give me 5-ethyl. And then on carbons 2 and 4, I have methyl groups, and they are identical to each other. So I need to use dimethyl. 2,4 dimethyl. Now here's the tricky thing. D comes before E, but we're not going to use the D. We always do our alphabetizing using the substituent name, and the substituent name is methyl. So we're going to ignore the di when we do our alphabetizing. So I actually wrote these out in the correct order already. 5-ethyl, 2,4 dimethylheptane. So that's 5-ethyl-2,4-dimethylheptane. Okay, our next rule. When two chains are the same length, you number in order to get the most substituents. Okay, so I have two examples here, and I drew each example twice so that we could number it different ways to understand why this rule is the way it is. So, both of these examples have two possible longest chains. There's this one versus this one. And then our next example, we have this one. And then there's no real competing longest chain. The only other thing is this, but that doesn't actually change the nomenclature process. So I'm wondering if I drew that example incorrectly. But we'll still name it. So for this top one, we have these two different longest possible chains. Let's go ahead and number them. So if I started down here, because this is my end closest to the substituent, that's one option. The rule says to number in a way that gives you the most substituents. So this second scheme is actually the correct scheme. Now the reason that we do this is because this gives us more substituents that are more likely to be simplified substituents, rather than this one, which would have its own set of parentheses and commas and hyphens as you're trying to name it. You can also use common nomenclature, which would be isopropyl, but we're sticking with purely IUPAC here. So this would be, the substituent itself would be called 1-methyl-ethyl, and you would have to put that in parentheses before the heptane. And that's a little more complicated than just saying 3-ethyl-2-methyl. So the correct name of this molecule is 3-ethyl-2-methylheptane. The goal is always to make sure that your name is as simple as possible so that anyone could read this name at any time and understand exactly what you're saying. And then also anyone who came up with this name should come up with the same name as you. So the simpler it is, the better. Okay, so for this next example, I think what I was trying to compare was if you number left to right versus right to left. So this rule comes down to trying to get the lowest possible numbers. So for this one, we have 2, 4, 5 as our numbering scheme, versus if we numbered from right to left, our numbering scheme would be 2, 3, 5. 2, 3, 5 is marginally better than 2, 4, 5. So 2, 3, 5 would be the correct scheme. So the name of this molecule would be 2, 3, 5 trimethyl, oh, I ran out of space, hexane. So this should be all on one line. 2, 3, 5 trimethylhexane. So this should be continuing here. Versus 2, 4, 5 trimethylhexane. Ah, there it is. That's what helps. The last rule. When branching occurs at same distance, aim for lowest numbers possible, which is what we ended up doing. And that branching occurs at the same distance is because we had the first substituent popping up at the same time. Okay, our last idea here is the classification of carbon and hydrogen atoms. When we're talking about carbon and hydrogen atoms, sometimes it's important to denote the difference in how substituted they are. So a more substituted carbon atom has more carbons attached to it. So we use a system of primary, secondary, tertiary, and quaternary. I'm going to color code these. We'll use orange for primary. We'll use this light blue for secondary. We'll use a yellow for tertiary. And then this light green for quaternary. So let's start with primary. Primary carbons are only attached to one other carbon. So this carbon is a primary carbon because it only has a bond to one other carbon atom, which is here. That is not a primary carbon though. This one also only has one other bond to a carbon atom, and therefore it is primary. So what you'll notice is that primary carbons tend to be methyl groups, CH3. So if you go through and choose all the methyl groups, you will have all of the primary carbons. Now, it doesn't have to be a methyl substituent. You can call a CH3 group that is part of the longest chain methyl when you're just trying to describe that carbon on its own. So even though the longest carbon chain in this molecule is this, and I would not be naming these using methyl, I can still call them methyl if I just want to talk about them. Next up, we have our secondary carbons. Secondary carbons are attached to two other carbon atoms. So you'll notice that these tend to have the formula CH2. So if you choose anything that has the formula CH2, you'll be finding a secondary carbon. So this is CH2 and this is CH2. So both of those are considered secondary. And we can use either the 2 with the degree symbol, or we can use the word secondary when we describe it. But the 2 with the degree symbol is a little easier to put down quickly. Next is tertiary carbons. Tertiary carbons are attached to 3 other carbon atoms. These are going to have the formula CH, and we'll have 3 things attached to the carbon. So this is a tertiary carbon, and so is this. Our last type is quaternary. Quaternary carbons have 4 bonds to other carbons. So there will not be any hydrogens on a quaternary carbon. And here is our one example of a quaternary carbon on this slide. Now, it says classification of carbon and hydrogen atoms. So all of the hydrogens that live on these different carbons get the same classification. Any hydrogen that lives on a primary carbon is a primary hydrogen. Any hydrogen that lives on a secondary carbon is a secondary hydrogen, and so forth.